interwebs. My name is Cameron Pasquale.
Sit down, Pasquale.
Our instructor is Mr. Michael Park, who has graduated from McKinley High School.
James?
From Castle High School. He has also taught at McKinley High School and Yolandi School.
St. Andrew's Priory.
And St. Andrew's Priory because he needed food and the food is free.
Hey, number 9. Didn't they draw the graph for number 9?
I don't have a book.
Yes. Here, let's do this. Number 9. We have to learn the last lesson for this semester today. So you got
That's the last.
y equal x, y equal 1, y equal x squared over 4. Okay, to compute the area of this region, can you see that you have to do 2 separate integrals? You gotta split it up like this. See, because the top minus bottom changes, right? The equations of the top minus bottom.
Wait, I did it sideways.
Oh, okay, well let's do it both ways then. Okay, so isn't this 1, y equal 1, right? I mean, 1, 1 and 2.
Yeah.
So how do you find the area of region 1 right here? Top minus bottom multiplied by the infinitesimal width, and you add up all of these rectangles from 0 to 1. And then to find the area of the second region, you go top minus bottom multiplied by the infinitesimal width, and then you add up all of these rectangles from 1 to 2, and then you add them together. Or, another way to do the problem is to just make horizontal rectangles. See, this one we're making vertical rectangles. But then, if you make just a horizontal rectangle, then you can just make one integral to get the whole area, yeah?
Yeah.
But if you do that, that means you gotta solve for x. So like in this one,
X equals
it'll be
2
x
root
equal
x.
y. And if you solve for x in that one,
2 root y.
2 root y. Okay, so what is right minus left? 2 root y minus y multiplied by the infinitesimal width. And then you add up all of these rectangles from 0 to 1.
No,
Y equal 1 up here, right?
The y.
You go from the y coordinate down here to the y coordinate up here. The y coordinate up here is 1, yeah? 0 to 1. Yeah, so you're doing the integral in terms of x. Why does that say FU on the thing? Follow?
What? Sorry, what?
Strike 1.
No.
And you're facing it right at me.
No, this is Mr. Steel Mori's assignment sheet. It says FUN. This is your legitimate assignment sheet. He handed this out. No, actually, wait.
Okay, sit back down. Sit back.
I didn't mean to insult you.
I didn't mean to F you.
FUN.
It's all
Okay, now the other problems, you have to draw the pictures on your own. So y equals secant squared x, y equal tangent squared x, between x equal negative pi over 4 and pi over 4. Okay, now before we even compute this integral, let's draw the picture. Now, if you have no idea what the graph looks like, how about draw the graph at the endpoints, plot points, and then plot a point in between. That's probably good enough for most problems. So here's negative pi over 4 to pi over 4. Which one do you want to draw first? Secant squared x?
Yeah.
Okay, what is secant of negative pi over 4? Oh gosh. Root 2 squared. So you get 2. What is the secant of pi over 4? 2. And then plot a point in between, like 0. Secant of 0 is 1, squared is 1. So I don't know, the graph looks something like that.
Cool.
Doesn't have to be exact. Okay, now what about tangent? What is tangent of pi over 4? 1. What is tangent of negative pi over 4? Negative 1, but you got to square it, get 1. And tangent of 0 is 0. So it looks like this. And then we want to compute the area from negative pi over 4 to pi over 4. So we want to compute this area right there. So can you see in this one, you definitely want to use vertical rectangles?
Yes. Yeah.
Because otherwise, if you make horizontal, then the right minus left, like right here, it's the same. You have problems. So this one, you definitely have to use vertical rectangle. So what is top minus bottom? So top minus bottom multiplied by the infinitesimal width. Add up all of these rectangles from. Now you can go negative pi over 4 to pi over 4. However, since we have symmetry here, why not just go from 0 to pi over 4 and times the answer by 2?
Ooh.
Well, this is not something exotic. Now, why is it beneficial to go 0 to pi over 4 and times the answer by 2? Now, some of you are just thinking, Mr. Park, I'd rather just go negative pi over 4 to pi over 4.
Because plugging in 0 is a lot easier than plugging in 5.
Thank you, exactly. Because most people can plug in 0, but then plugging in negative pi over 4 is a problem, especially in AB. Okay, now, do you guys know how to compute this integral?
Wait, isn't secant squared minus 1
Yeah.
1?
Exactly. Hey, you somebody.
1.
That's 1. So that's like the easiest integral you can have, right? The antiderivative of 1, here I'll go one more step. The antiderivative of 1 is x. So from 0 to pi over 4, factor out the constant. Can you see the answer is pi over 2 then?
Yeah.
Okay, I'll go one more step. Pi over, plug in the top number, plug in the bottom number, and subtract pi over 2. What was that?
5 over 2.
Say that again? Oh yeah, but lots of times we have trig functions, yeah? Okay, 32, 34. Oh, these are suspiciously even problems. X equals 3 sine y, radical cosine y, x equals 0, between y equals 0 and pi over 2. Okay, Mr. Park, I don't know what that graph looks like. Neither do I, but at least you can draw a sketch.
There's a calculator problem.
No, this is not a calculator problem.
On the book.
Well, how do you graph that on your calculator then? This is not a function, that's why. Because it's x equals.
I did.
How do you punch in x equals on your calculator?
You can.
You can?
X equals.
On the Casio you can?
Yeah.
Wait, do it.
Really? Okay, on the TI you cannot. Anyway, no calculator.
What?
Anyway, if I get this on the test, there's no calculator.
Aww.
Like I said, plot endpoint and then plot a point in between. So what happens when you plug in 0 for y? What do you get? Plug in 0 for y.
Yeah.
Sine of 0 is 0. Okay, so you get there. What about a pi over 2? Plug in pi over 2. Cosine of pi over 2 is 0, so 0 times anything is 0. And then plot a point in between like pi over 4. I don't know what it is, but it's going to be some positive number, right, for the x-coordinate. No, that's all you got to do. So the graph is going to look something like that, and then x equals 0 is this. So this is the region in question right there. So can you see you definitely want to use a horizontal rectangle? Because if you use vertical rectangle, the top minus bottom is the same curve. And what happens if you get problems?
And it's x equals.
Yeah, and the biggest hint is x equals. That's a hint to do horizontal rectangle. Okay, so what is the length of this rectangle? Right minus left. So that would be this minus this. So 3 sine y root cosine y minus 0. Do I have to put the minus 0? Well, I'm not gonna. Multiplied by the infinitesimal width. Add up all of these rectangles from
0 to pi over 2.
Okay, you guys are getting trained. Now the question is, can you compute this integral? Now the integrals that they give you in the book are so easy. Wait till you see the ones on the test. Then you gotta use trig substitution, partial fractions.
Dude.
Like this one is what? You look at this, what are you thinking?
Easy.
U substitution. U equals...
Cosine y.
Do I have to do this or can you guys do it?
No, you have to do it.
I'll do it for the video. u equals cosine y,
For the video.
du is negative sine y
Okay, put a y.
y. So this integral becomes, let's throw the 3 on the outside. Radical u is that, and what do I substitute for sine y dy? Negative du. And what are the new limits of integration? If I plug in 0 there, you get?
1.
If I plug in pi over 2, 0. Okay, so that's negative 3 times. The antiderivative of that is u to the 3/2 with the 2/3 in the front.
God bless
From 1
you.
to 0, factor out the constant, haga haga, negative 2 times, plug in the top number, 0. Minus, plug in the bottom number, 1, final answer, 2. See, what do we use a calculator for? Nothing.
I use it.
Maybe pedestrian students use a calculator, but we're ELN, we don't need a calculator.
Wait, don't erase it.
Why, I got a video,
I know, that's why I want to see the picture.
screenshot.
No, that takes time because you gotta look
Can you
for it.
screenshot video?
Yeah.
Yeah.
You can screenshot
I don't
anything
know.
on your screen, Mr. Parker. That's not a screen. No! No!
I thought you just meant that problem.
That's a lie.
Yeah,
You
he
knew.
doesn't.
I didn't know. I didn't know you wanted this easy one. Anyway, weren't you the one that said you did one integral?
Yeah, I did, but then what if I want to look back at it?
Look at your paper. Oh my, okay, I'll just erase those. Okay, next, 39. Yeah, these aren't that many problems. You guys did pretty good there.
Yeah, we cut it down. It used to be long.
39. Find the area of the triangular region, triangular in quotation marks, in the first quadrant, bounded on the left by the y-axis, on the right by the curve y equals sine x, which means that's pi, and on the left at y equal cosine x is like this. Oh, wait, that's pi over 2. So cosine x is like this then, right?
Yeah.
So what triangular region are they talking about?
That one right there.
Yeah, right here. Now, this problem can be done both ways, but see, the top curve is y equal cosine x. This is y equals sine x. Can you see that you definitely want to do vertical rectangle?
Because it's
Because
y
if you do
equals-
horizontal, then you gotta solve for x. You're gonna have x equals sine inverse y, x equals cosine inverse y. That's humbug to integrate. Yeah? You gotta do integration by parts. So why not just keep it this way? Okay, so what is the length of this rectangle? Top minus bottom. Multiplied by the infinitesimal width, dx. Add up all of these rectangles from
0 to
0 to, oh,
Five.
Mr. Park! What, I don't know where that is, bro.
root 2 over 2.
No, it's not root 2 over 2. It's
Pi
pi
over 4.
four.
That's what I was talking about.
Yeah, but that's not what you said. Everybody see why it's pi over 4? Because sine and cosine are both root 2 over 2, so that's why they intersect there. Or if you can't figure it out in your head, if you can't guess and check, what do?
You equal each other.
Don't ever say set them equal to each other.
I did it.
Substitution.
You equal
And
each
then
other.
when is sine equal to cosine? Pi over 4. Or how about this? Divide both sides by cosine and you get 10x equal 1. Pi over 4. Or how about this? Divide both sides by sine. 1 equal cotan x. Pi over 4. Right? I think it's easier just to do it by inspection. And then, come on, this integral you guys can do, right?
Yeah.
Okay, I don't need to do this.
Wait, I just wanted to know the answer. Oh wait, never mind.
Gosh.
Wait.
This is odd. This is an odd problem.
Wait. Yeah, no, wait. I got that. But then.
No, you know what? I'm not doing it. That's just too easy.
Oh, never mind.
It's beneath us.
I forgot to plug in 0. Got it.
Oh yeah, that's a common mistake in AB. You know, just because you plug in 0, almost all of them think, oh, the answer can be 0. But no, you plug in 0 into cosine, you get 1.
Yeah.
You plug in 0 into e to the x, you get 1. So if you plug in 0, you don't always get 0, fool.
That was my comp.
Okay, number 42. Find the area of the region. Okay, so I guess the hardest part of this problem is to draw the graph. Right, Joe?
Oh, yeah.
What is that laugh?
I don't know. seemed funny to me. Oh, that's kind of crooked, the line.
It's okay.
Y equal x over 4.
Everyone's beautiful.
Okay, above left by the curve, y equal 1 plus root x. So
Yeah,
that's the
what-
root x
what is
graph shifted 1 to the up. So it looks like this. Y equal 1 plus root x. Okay. And then above right by the curve, y equal 2 over root x. So 2 over root x, if you plug in 2, you get 2. What happens if you plug in 4? You get 1. So it looks like this, yeah? So what region are we talking about here?
That one.
Wait, let me read again.
It's right there.
No, silence. Oh yeah, it's this one. Because it's bounded on the left by the y-axis.
And then the top left is the big.
Yeah, so that's the region. Can we do this in one integral?
No.
No, so we gotta make separate integrals. So do you wanna do a horizontal or, wait, let's write in the equation. Y equals 2 over root x. I think we wanna do vertical rectangles, yeah?
Yeah.
Yeah, so, can you see that you gotta go 0 to 1 and then 1 to 4, right?
Wait, how do you know that that's one?
Because I drew the graph
Oh,
by plotting points, right?
Oh yeah, because you
Yeah,
substituted.
that's 1. Okay, so this first region over here, top minus bottom. See, that's why, look, you have everything in your picture. It's easy to see which one's on the top and the bottom. So top minus bottom multiplied by the infinitesimal width. Add up all of these rectangles from
0 to 1.
0 to 1. You gotta wait till the sound. The second region, top minus bottom. So you got top minus bottom multiplied by the infinitesimal width. Add up all of these rectangles from
1 to 4.
1 to 4, and then add them together.
What does that spell?
And this is no calculator. I don't care what the book says. This is no calculator. Well, what does the book say? That's weak.
No, 42 is calculated.
Wait, what does it again mean? The shaded one?
The shaded
means-
one is no calculator.
As far as I'm concerned, all of these are no calculator.
You should have told me that yesterday.
Okay, you know what? You don't use your calculator unless it says so on the assignment sheet. No, it does
It
sometimes.
always says
No.
no calculator.
Yeah.
Doesn't even say anything at this point.
You only
Really?
There was one
There's
question.
one like
There's like one.
Okay. Okay, here.
Number 7.
Okay, forget all of that. You just use your calculator when it's absolutely necessary. Now, some of you are thinking it's always necessary.
Yeah, what? Yeah, what?
Okay, so is that it? Can we?
Uh,
Well, what about the graphic calculator one? What do we actually? Are you guys sure you can do that? Because there's gonna be several of those on the test. Yeah,
Yeah.
Baba,
Could you explain how you got the graph into
I drew it.
Oh, no, the other one. Okay, well, actually, the 2 over root x.
Are you serious?
Yeah, done.
Well, you can see already the vertical asymptote is x equals 0, right?
Yeah.
How do you tell when you have vertical asymptotes? When the denominator is 0, right? How do I know the horizontal asymptote is y equals 0, the x-axis?
The power.
Because if the degree of the bottom is bigger than the top, then it's y equals 0, right? What's the degree of the top?
0.
What's the degree of the bottom?
Half.
1/2. 1/2 is bigger than 0, so the horizontal asymptote is going to be y equals 0. So you know it's going to look like this, but how do you know what's in between? Well, let's plot some points. What happens if you plug in 1? You get 2. What happens when I plug in 4? You get 1. And 1. Okay, now we're doing 31.
Can you say what the answers Figure out to know where it is.
11/3.
For what number?
Good job.
For 42?
Oh, I wanted to do it in my head. You got if you don't push yourself, then you're never gonna be pushed.
What about if other people push you?
31. y equals sine. Hey, somebody better ask.
Philosophy with Mr. Barr.
Somebody better ask. Somebody better ask the one where you're using your graphic calculator. Like number.
7.
Oh no
That one's easy.
Number.
That was
Yeah,
only
number
one.
7.
What was that answer?
Number 7.
For what number?
Someone I took from very
Yeah, but you better know how to store on your calculator. and
I
stuff.
did, it's the arrow.
Okay, silence now. I'm drawing the graph now. Okay. Y equal x. That's a duh, right?
Wait, what problem?
1, 1. But sine of pi over 2 is 1, and then sine, negative pi. Oh, so it looks like this. Right? Did you guys get that? Now, can you see, because these are odd functions, that this area is equal to that area? So why not just compute the area down and times it by 2?
Hey.
That makes sense, right? But you only can do that if you have symmetry now. If you don't have symmetry, you can do. Okay, so how do I find the area of this one? Make a vertical rectangle. What's the length of the rectangle? Top minus bottom. So sine of pi x over 2 minus x multiplied by the infinitesimal width. Add up all of those rectangles from 0 to 1, but there's 2 of them, so times it by 2, boom. Well, what was the problem?
There was.
Wait, why?
There's a problem, right? Yeah.
What?
I wanted to separate it from the other problem. So you can see it better.
Now, don't
And then you guys have any problems doing the antiderivative of this?
No.
No, because the derivative of the box is constant, right?
Don't erase it.
You can
Don't
adjust
erase
it.
it yet. Thank you. What a photogenic guy.
Okay, and then can everybody do number 7 then?
Yeah.
You sure?
If not,
And everybody got 3 decimal place accuracy.
I'll teach a class during
Okay.
lunch today.
No problems there.
Wait, I don't know how to store it though. I just wrote it down.
Oh yeah, but come on, you have a calculator. Store.
No, it's the arrow.
So-
It's the arrow.
Oh yeah, the arrow. Yeah. Yeah, if you want to write it down, go ahead. You live in the Stone Age. Live in the Live in the Stone Age with me.
He's like, no thanks.
So like, you draw and then you.
What are you doing? We learned how to use the graphic calculator extensively in PCH. If we're not storing by now,
No.
He gave us a long thing of paper and then he's like, here you go, just write it down.
but on my notes I have how to use it. Wait, time out.
Oh, cool.
I saw it.
Yeah, whatever.
Okay, let's do today's lesson so we can finish early today. Okay, this is the last thing we're learning in the second quarter. 8.4, length of curve. Okay, 8.4, now what the heck is this? Now remember, basically an integral just adds up an infinite number of tiny things to get the whole thing. That's what we're doing here. Okay, now, Mr. Barb, how come we're skipping 8.3? That's because it makes more sense to do 8.4 first. 8.3, you know what? Here, let me give you a preview of what we're going to be doing in 8.3. Because when you go to the movies, don't you guys like to see the previews of what's
Yeah, I love the preview. That's the best part.
Here's the preview of 8.3. R is the region bounded by the graph of y equal root x and y equal x over 4. Okay? Okay, now, see what we're doing in 8.3 is three-dimensional thing now. You gotta be able to think three-dimensionally. This is the base of a certain solid. Okay, think about it. So it's a certain solid, I don't know what it is, it's a three-dimensional thing. Every time I take a slice perpendicular to the x-axis, you will get an equilateral triangle. Can you imagine what that looks like?
Yeah.
What?
What? It's like.
So like over here, so it's like whatever this thing is, you put it on a cutting board. If you take a slice right there, you get a small equilateral triangle. And over here, it's bigger. But then over here, okay, it gets smaller, and then like over there, it's a very tiny equilateral triangle. So every cross section is an equilateral triangle, except it's small, and it gets bigger and it's bigger. Here, let me attempt to draw this. Do not attempt this at home. That's bad, yeah.
What is that?
I'm trying to draw it. I'm not good art. I'm trying to draw the thing.
Is it like a code type of thing? Like it has like a ridge something else?
Okay, God, that's terrible. That's terrible.
I don't understand.
I know, because that's a terrible drawing.
I don't get.
Okay, let's not attempt this again. Okay, so here's the x and the y axis.
Dude.
Okay, so every time you take a slice perpendicular to the x axis, you can get these equilateral triangles like this.
Well, it's an armadillo.
Yeah, it's like a slug. That's what it is. It's like a slug. You guys know what a slug is? Okay,
Do you know what a slug
the
is?
slug. Find the volume of the slug. No, we're not gonna do it now. This is a preview, okay? Okay, but what if I said the cross sections, instead of being equilateral triangles, are semicircles now?
Dude.
We have smooth slug.
Yeah, exactly. So it's gonna be like a woo, 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 woo,
Ha,
woo,
ha,
woo,
calm.
So what is that? That's like half a croissant, yeah?
A what? A what?
Croissant, you slice it in half.
Oh, wait. A what?
Croissant. Croissant.
There's an R.
That's how you say it, right? Croissant. It's not croissant, it's
Yeah, but you
croissant.
don't
It's
say
a
it exactly
croissant.
correctly either. You just say like W instead of R.
Wait, what is it?
Croissant.
But it's not croissant.
Okay, whatever.
But it's not quasi.
Okay, here are the other things we're gonna do. What if you took this region and you revolve it about the x-axis?
No.
It's gonna be ugly.
You're gonna get this three-dimensional thing that's it's like a vase, but the inside
Is a V.
is just a cone.
Okay, drop.
Why would you want a base with
I don't know why you would want to.
No, but then,
It's
but
kinda
then
like
the bottom of the base.
what is the
width
volume
is
and the surface
nothing.
area of this?
The bottom of the base
base?
is nothing.
Okay, what about this? What if you took this region and revolve it about the y-axis?
That's
It's even less.
Oh no, that's cool.
You get like a vase,
That's a great fit.
but the inside is like padded. What is the volume and the surface area of this solid? Anyway, that's a preview of what we're doing in 8.3, and if you look at your assignment sheet, we're spending 4 nights on that.
Oh my
That's how
goodness.
important it is. Okay, anyway, what we're doing is find the length of a curve. Like if you have a curve, how do we find the length of it? See, if you have a straight line, easy to find the length, right? Just use the distance formula. But in real life, it's not gonna be straight line, right? So what do? Because most things are curvy, right? How do you find the length of the curve from like x1, y1 to x2, y2? What do? Well, what we do is just like we did with areas, you take an infinitesimal piece. So what if I just took an infinitesimally small piece of curve right there? Now, if you zoomed in, what would you see? Zoom in on that, what would you see? Yeah, well, it wouldn't be straight, it's still curved, but it kind of looks like a straight line. So just imagine, what if you zoomed in on that like 1,000,000 times? What would you see? It would look like a straight line, but it's not really straight, but it's almost a straight line, yeah? No, there's no thickness. There's no thickness, okay? So, how would you find this? Well, what if you drew this in? Well, this is an infinitesimal change in x, so what do you think we call it? dx. This is an infinitesimal change in y, so we call that dy. So, here's the most important part. What is this right here? Shh. What is this?
To infinitely test
Square root, come on, just use the Pythagorean theorem. Square root of
dx squared.
dx quantity squared plus dy quantity squared. And what do you think we're gonna do? Once we have this, We're just going to add up an infinite number of them. Right? So we're going to add up an infinite number of these to get the whole curve. Okay, but the problem with this is, when you do an integral, you're either going to do it in terms of x or y, right? And if you do an integral in terms of x, you need a dx out here. If you do the integral in terms of y, you need a dy out there. Here, let me get that for you. So, how can I get a dx out here? How can I get a dx out here? Come on, use your math skills. Yeah, you factor out the dx squared inside the radical. And what's going to be left if I factor that out?
1.
1 plus dy quantity squared over dx quantity squared. Okay? And then, what is the square root of dx quantity squared?
dx.
Absolute value of dx. But dx is a length, right? So it's positives. So we don't need absolute value. You guys see that? And then what's left? The square root of 1 plus. Now, since both of these are squared,
dy
we can just do this.
dx.
See, you can treat it like normal
Yeah.
fractions, the Leibniz's form of the derivative there. And since you're doing the integral in terms of x, you're going to integrate from the x coordinate here to the x coordinate there. Boom! That's the formula you're going to use tonight. This is how you find the length of a curve.
So we can just use that formula?
Yeah, that's why I boxed it.
Okay.
Okay, now what if you're doing the integral in terms of y? Then what would you do? Instead of factoring out the dx quantity squared, you factor out the dy quantity squared. What do you think you're going to get? Can you guys see it? Or do I have to do it again? It would be the square root of, if you have a dy out here instead, what's the only difference? 1 plus dx over dy quantity squared. And since you're doing the integral in terms of y, you go from the y coordinate here to the y coordinate there, and that will give you the length of the curve. So you have to determine, am I going to do it in terms of x or am I going to do it in terms of y? Okay, let's look at 2 examples and then that's going to be good enough. I like the sine curve here. Here is the sine curve. Y equals sine x, 1 hump. From here to here, find the length of the sine curve. From there to there, find the length of that. Okay, look at the formula. Look, since it's y equals, you're going to use this one. You're going to do it in terms of x, just like last night's homework. So notice that what you got to do is you got to find dy dx. What is dy dx again? The derivative. So to compute the length of the curve, you got to be able to compute a derivative. So if y equals sine x, what is dy dx? The derivative. Have we forgotten our derivatives?
Yes.
No, come on, that one's easy. It's cosine x. Once you compute the derivative, just plug it into this formula. So you got the square root of 1 plus whatever the derivative is, squared, dx. That represents an infinitesimal tiny piece of curve. And then we're going to add up all of these tiny pieces of curves from the x coordinate here to the x coordinate there. And what would that be? 0 to pi. So this integral will give you the exact length of that curve right there. Now, this is what you have to decide. Can I do that by hand? Or do I have to use a calculator? Come on, look at this. Is it on the list?
No.
Come on, go through your reads. Is it on the list?
No.
Can I make a u substitution?
No.
Can I do integration by parts?
No.
Can I do partial fractions or trig substitution?
No.
Okay, then you take out your calculator and punch it in. Okay, go. And Laura, go.
I'm going.
How come when your coach tells you go, you go? And when I tell you go, you just look away?
Wait, you're blocking it. You're blocking it. You're blocking it. Why do you do this?
Who's the coach?
Dean Young.
I'm talking to Dean Young today. He was my student, you know. My very first year at Iolani, 1988, 1987,
I've got it.
he was in my PCH
Great
class.
Scott.
He was smart.
Want to say that again for the video?
Wait, Coach Dean was
Yes, he was in PCH and he went to BC. Now he's like a he's a
dude.
district attorney, right?
Yeah.
Coach Dean is a very cool dude. Okay, he coached me in football.
Yeah.
Now the answer is 3.820.
Wait, isn't that?
I believe that's correct, because you think they do this every year in AP.
No, the boys coach is Dean and the girls coach.
Oh yeah, Dean Shimamoto.
Yeah, that's
No, that's Dean Young. Dean
They're both
Shimamoto
Deans.
works over here in the IT department.
And
Yeah.
who's
I taught him in PCH and I think he grad 1994 or something, 1994. He went PCH. They both were A students too. They both went to BC.
yeah,
Yeah, they were like just
And
scratching to get
Shimamoto-
high.
Dean
They were A
Shimamoto.
students.
He's also married to Teresa Shimamoto.
Okay, I didn't teach her.
Yeah.
Did she go to Yelani?
No.
Okay, well that's why I didn't teach her.
Teresa.
Okay, did everybody get 3.820? Nomura.
Mm-hmm.
Don't you lie to me! I'm kind of doubting that you even have your graphing calculator.
No, it's a surprise.
Now, did somebody not get 3.820? I just want to know.
I didn't.
Huh?
Whoa.
You got it. Okay, because if you didn't, then maybe your calculator's in degree mode instead of radian.
Yeah, I changed
Come
my
on,
hair.
when you do trig functions, you have to be in radian mode. You guys know that.
No, don't erase it.
Okay, now we're gonna do the hard one. Let's just see how fast. See, this is the kind that's gonna be on the test. Now, why would I put something that easy in the test?
You wouldn't.
I wouldn't, that's right. Now, here, this is a taste of what's gonna be on the test.
Ooh, I love to eat.
Okay, here is the graph of y equal x squared. Find the length of the curve from here, 0, 0 to, what do you want to do, 1, 1?
Yes,
That's
please.
good enough. Find the length of the curve right there. Now, first of all, you want to do this in terms of x or in terms of y?
In terms of why?
X.
Why?
At.
Why?
Oh wait.
Okay, let's compare the two. What if you did it in terms of x? So first of all, you got to find the derivative. dy dx equals 2x, correct? So now you plug it into the formula. Square root of 1 plus the derivative squared dx, and then you add up all of these from the x coordinate here to the x coordinate there. You know what? I changed my mind. I don't want to do 1, 1. I want to do 2, 4. You know why?
No.
Because if you do 1, 1, the people who are think are doing it in x, but they look at the y coordinate, they will get it right. So if I change it, then so since you're doing it in terms of x, you go from 0 to 2. Okay, now think about that. How do you do this integral? 0 to 2, square root of 1 plus 4x squared dx. How would you do this integral? Trig substitution. That's right.
No.
And then just as a review, let's see. What would I let x equal to?
Sine.
1/2.
Oh, very good. Cho is on fuego today. 1/2 tan theta. Remember the trig substitution?
Who
we
says
said?
that?
Yes or no? Is this gonna work? You guys remember trig substitution? Okay, you know what? Let's just go a couple steps because some of you are just going, what? dx equals 1/2
Sine.
secant squared
Theta.
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 Oh my goodness. Okay, so this integral becomes the square root of 1 plus 4. If this is x, what is x squared?
Something.
1/4 tangent squared theta. And then what is dx equal to? 1/2 secant squared theta d theta. And then I'm going to add all of these up from, when you have a substitution, the limits change, yeah?
Yeah.
What are the new limits of integration going to be?
Ooh,
Well, if I plug in 0 for x here,
Yeah.
tangent theta equals 0. What is theta?
1.
What?
0.
0!
0.
Oh my gosh! Now what happens when I plug in 2 here? Then you get tan theta equal 4. Tangent of what angle equals 4? Tan inverse 4, that's right. Already it's ugly. Okay, now what? This 4 cancels the 1/2 in. 1 plus tangent squared theta. You somebody. secant squared. And what's the square root of secant squared?
Absolute value of secant.
But on this interval, it's positive, so it's just secant. So what integral do you get?
Secant cube.
Let's put the 1/2 on the outside, you get secant cube theta d theta. Now remember, you did this when we did integration by parts? This was on test, by the way. And remember, I told you guys, when you go to college and you enter the integral B, you want to memorize this one. Anyway, those of you taking multivariable calculus next year, this one got to be memorized.
No one's gonna go through the integral.
Okay, yes. I had students come back and visit me, they said they entered it, but they got out on the first round.
That's not gonna be Jason Cho. Jason Cho's gonna make it to the finals, and then he's gonna win the
Integral B.
integral B.
What is so funny about an integral? Okay, let me just ask somebody, redeem yourself, the moral.
Give it to me.
What's the integral of secant cube? At least you made eye contact.
Let me think.
1/2.
You just laughed at her.
Anybody.
1/2
No.
Square theta.
Secant theta, tangent theta, plus 1/2. Cho? You guys are just guessing. Secant
Wait,
theta
whoa.
plus
Wait,
tangent theta.
wait, so what I-
How are we supposed to know
Wait,
that?
what?
0 to tan inverse 4. I told you guys when we did the problem that it's gonna come up again, and here it is.
Yeah, but why would we need to memorize it? We're not going to the integral B yet.
Yeah, but
Yeah.
you're gonna be taking the test next week, aren't you? Okay.
Well,
Now, if you cannot remember the integral of secant cube, then what do you gotta do? You remember what you do? Yeah, you gotta split that up into secant times secant squared, and then you gotta do integration by parts. But then you gotta do it, and then you gotta bring it over. Remember solving for the unknown integral, that thing?
wow.
Oh, Mr. Clark, that's painful. So, maybe the best way wasn't to do it in terms of
See, that's
x.
what I said, in terms of y.
What would happen if
What
we
the
did it
heck?
in terms of y? But if you're gonna do it in terms of y, you gotta solve for x. X equals,
Square root of y.
okay, square root of y. Then you gotta find the derivative, dx dy. What's the derivative of that?
1 over 2
1
root y.
over 2 root y.
Oh, camera Pascal.
Okay, so you got the square root of 1 plus this thing squared. Can we just square it? 1 over 4y dy. Add up all of these from 0 to 4. Since you're doing in terms of y, you gotta go from the y coordinate there.
Neither.
Now I'm looking at that thing. You can't even do that by hand. So your only choice is to do it like this. Yeah.
Oh, do it again.
Okay, I'm just telling you. I'm telling you right now, and a lot of you are going to take multivariable calculus in college next year, right? If you guys go.
No, wait, no.
Oh, by the way, I just got an email today. I'm certified to teach.
What's on the survey?
Sit down. You're embarrassing.
I'm not in the video though.
No, for real. You need to memorize this. What?
It's been like a long time. 3 months. You said 3 months.
I'm sorry. I wrote the angry letter and things happened.
Wait, what did they say? What did they say?
Did they address your integral? Yeah.
No, they didn't address it.
Did they say
Anyway. Anyway, can you guys finish this problem?
No.
Oh my god.
Yeah, you gotta draw a triangle. You know what? We're not gonna stop until we actually get the answer.
We're not gonna stop. Not gonna stop.
1/2. Okay. Shh. 1/2. In fact, why don't we just factor out these 1/2s into 1/4 then?
Yeah.
Thanks. Okay. Plug in tan inverse. Who's gonna plug in tan inverse 4? Well, tangent of tan inverse 4 is 4, right?
Yeah.
But what is secant of tan
We
inverse 4?
have to draw the
Yeah,
triangle.
you draw the triangle. What is that? Root 17?
Yeah.
So what is the secant of that angle?
Root 17.
Root 17
That's so gross.
times tan inverse 4, which is 4, plus natural log of
This one's gross.
root 17 plus 4 minus,
0, just
minus, if you plug in 0, you get 0 plus natural log of 1 is 0. So your final answer can be root 17 plus natural log of root 17 plus 4 over 4. There, that's the length of that curve right there.
Wow.
Can you repeat this on the test?
No.
What if I change that to 3,9?
I can't even do that one.
Well, how about like study it? Some of you think you watched the movie once and you got everything down already.
Yeah.
Like for me, I need to watch the movie 2-3 times before I get to
Yeah,
understand.
but you didn't even watch Moana once.
You didn't watch
I
one.
don't want to see that.
It's a great movie.
Although while I was waiting for
You heard
the
crazy.
office Christmas party, I was just waiting around, so I went into Sing. I watched Sing for about 20 minutes.
Did you watch Frozen?
Sir.
Yeah, when it came out on Foot Locker.
Wait, which song? Or which movie?
Frozen.
Wait.
Okay, we are done. This is the last thing that we are learning. And then I put up a practice test on there. Now, I would say half of them you're gonna get to use your calculator, but see, on this test, you're only gonna get 40-something minutes, so I can't give you all of those problems. I'm gonna have to take out some. So just make sure you can do it both ways, with the calculator or without.
If you Google this is a good site to watch movies on.
Why?
Because there's a lot of movies on there.
And you can get it easily.
I just go Foot Locker.
Yeah, it's a free part.
Footlocker.is.
It's free.
Yeah,
So,
but now they changed it, yeah.
Oh yeah.
I have a box.
I go on movie
Amazon Fire
4K,
box,
that's
This is
all.
any movie you want.
Yeah, but I heard about those boxes. It just searches these sites, right? That's what it
That's
does.
what it is, and you'll get viruses.
But then how much you have to pay for the
Oh,
box?
well now it's on
Oh,
video.
I hacked it myself.
Wait, can you
But
do
it's
that?
an Amazon Fire.
I'll pay you for
Wait,
it.
okay, we're done. Let me, 1, 2, 3 movies.
$100.
Let me check that out. Let me check. Hey, don't be saying stuff like that when the thing is videoing.
Do you know how to edit it out?
I've forgotten.